Okay, so I created a little coded example of a trained model so you could see kind of how this would work in principle. Head over to the CodePen model linked in the description. And what you'll see when this loads up is there are 3 points. And there's a kind of an XY plot. And the curve, there's like a pink curve. And it is fitting the points that are there. So if you're the uninitiated looking at this, this probably doesn't make a whole lot of sense of why this would be machine learning, but I'll break it down. The points are training data. And so the training data has allowed the model to fit this curve such that it goes through the points. It compensates for the training data. And just like we've been talking about these tests, like does it pass the test or not pass the test, just like our GPS points, does it fit that format or not? The way that you interpret these graphs is that the training points fit the curve, and the model then is set of these layers of tensors. And so this is a very simple example where there's 2 dimensions. There's an X dimension and a Y dimension. And so in this little, in concept example, those are tensors. So we have 2 tensors. And the model is showing this curve. If the new data point that we feed it, like our new string that has the GPS points in it, if we feed that to it and the point ends up being underneath the curve, that would be a positive match. So if this whole setup, this graph, represents the test of whether this is GPS points or not, and the point that we fed it falls underneath that curve, we could say, yes, this is a GPS point. If the point instead falls above the curve, so outside of the curve, we would say that's a no, that's not a match. In addition to that, we could say the distance from the point to the curve, that's our confidence. So if it falls above the curve, we'd say, oh no, this is no match. However, if it's really close, we would say, well, the confidence isn't really high, but it's still a no match. So what you're looking at on load of this little prototype that uses TensorFlow.js, by the way, is it's looking, and it just has 3 points. So the curve is trying to fit the 3 points. If you look into, on the right side, there's a code panel there that shows all the source code that makes this work. And you look on line 4, you'll see I start the seed data. This is the number of training values that I put into the prototype. So on line 5, you'll see there's a seed number and it's set to 3. Try setting that to 30. You can just change the number to 30 and it will automatically update. And you'll notice that now the training data has been a lot more, it's filled in. You can see that it's almost starting to make a curve, and then the model fits it as best as it can. So the value of having more training data is that the model is more solid. So in our case of each one of these data ontologies, they're not going to be, just, two tensors. They're not going to be just an X and a Y tensor, and they're simply not going to be like, values like this, like, X and Y values. In fact, a lot of them, like we've been talking about, have been Boolean. Like, does it match this pattern, or does it not match this pattern? So that would be a 0 or a 1. And so you're looking at a very simple example that's in principle how this would work, but we couldn't really easily visualize the sum total of all of our tensor layers for our ontology that we've been talking about this whole time. It'd be difficult to kind of visualize that all in one space, because it's like, several dimensions as we're trying to fit this curve in several dimensions and then determine whether it's underneath or above that and then get our confidence score from it. But that's in principle how it would work. One thing I wanted to show you about this, and we get into the crux of machine learning, is if you drop it back down to 3, drop the seed number back down to 3, so we just start with 3 points, the prototype will reset and you'll get a curve. Now you can also click on here to add points. So let's suppose that the 3 that are already there are the training set, and then you're going to add one more training set point. You can, when you click a new point, it attempts to reset the curve to compensate for your new training set, your new training point. So the curve is now different. That's the learning part of machine learning. And you can kind of just keep dropping in points to try and get it to fit the new curve, and you can kind of mess around with it, and you can see how it responds. So as you just kind of click points around. So notice that you can get a large change in the curve if it only starts with 3. Now try jumping this up to 300. So take the seed number on line 5 of the code on the right panel there and jump that up to 300. So the prototype will reset and it will start with 300 values. Now you can see that the function that I'm using to identify the seed number training points is this bell curve. You can clearly see the bell curve now, and then you can see the model trying to fit that bell curve. Now try clicking points, way above and way below, and you'll notice the model doesn't change very much. The curve doesn't change. It's because it's already been trained on a really solid data set, and these random points that you put in aren't affecting the model that much. So what this shows you is that the value of the training set and how solid the training set needs to be. So the ontology needs to be encoded, embedded in our tensor layers, and it needs to be very solid because we're not going to have very much change. There's not going to be additional learning as the user goes in and says, oh, no, I don't want to see these GPS points as a map. I want to see them as a table and that sort of thing. So this is kind of an illustration of how this stuff works and the value of training and the sensitivity of a model after it's been heavily trained versus when it's been not so heavily trained. The take-home point is that we've been talking about these TensorFlow layers and these kind of ontology tests for various data ontologies and the domain of the data, like our GPS points. There's no way that I'm going to go in and create a set of ontology tests for every single data type and domain known to man. Like, it's just not going to happen. That's where machine learning comes in. See, what I want to do is I want to figure out a generic test for all the kinds of ontology components, and then I want to use machine learning to go and recurse into various sample data sets to figure out all of the information that I can glean from the pattern of the data that's presented itself, and then I want it to generate all of the curves for me for each of the data types. Then I'm going to use those as the tests. So I'm going to have machine learning learn all of the formats for me. Okay, so I'm going to show you one last prototype here. This is what I've got so far. So if we put all of these concepts together where I have some remedial trained models and some basic ontology types being mapped onto data, you'll see in this UI, and this is my working model of my AUI system, you'll see I have a tab that says UI on the top, and then I have a tab that says data. So in the data tab, you'll see I have an editor here, and I can drop data in place. So for example, let's say that instead of this array of objects that I'm going to use in a second, let's say instead of that, I drop in a string, and it's just going to be a color. So it's FF3399. So it should be a color. If I hit the Build UI button, and I go to the UI, notice that it dropped in like a little color chooser, and it was set to that value. So it has learned the type for hex code color values, and it's mapped that remedially to a little color chooser. So if I go back to the data tab here, and instead I drop in this object, and you'll notice that it has name and Seattle, Bozeman, Duluth, it has populations, and it has states as locations. If I hit Build UI, and I look at what it did, it dropped in a table. So it recognized that array of objects as a table element. That's like the canonical form of the display of that particular information. So I drop in a string that's a color. It says, oh, that's a color. It learned that model, and it has a remedial mapping to the color chooser. In this case, it maps it to a table, a data grid. And you notice I can sort and filter the table to show the information that was there. However, what if I slightly change it? So instead of the object where it has the locations as these state names, let's suppose that I drop in almost the same data. It's just that I've given it a location, and instead of the state, I've given it some GPS coordinates in a string. So the same observed type, like the state name was a string, and this time the string is some GPS coordinates. And if I hit build UI and I go to the UI, you'll see that it has learned this type as a map. It knows that those were GPS coordinates, and it has rendered a map to the screen that shows me those locations on the map. So this is a simple example of how all of these pieces fit together. We have some data. It passes it through some machine learning models in order to determine which type of data it is, to extract its native type, and then to have a remedial mapping to a UI object so they can drop it on the screen. So there's a long way to go, but that is an example of how we get through that first of 4 layers of just detecting the type and trying to extract the ontology from it.